Pure Handbook 1, Lesson 3, Gradients and Lines. In this video, we're going to start off by finding the gradient between 2 points. So we have our first point here, which we're going to define as x1, y1, and the second point is going to be x2, y2. If I want to find the gradient, I just use this following formula. Try and get the habit of using this formula rather than just think of it as changing y over changing x, because you've got to be very careful that you get the correct sign when you do this. So let's have a look at some examples. So as you can see, I've done this first one for us. So it should be nice and simple this, just using the formula. You've got your 2 points. So on top we do y2 minus y1, so the 5 minus the 1, and on the bottom we've got 4 minus 2, which is going to give us 6. Remember, minus 2 is the same as plus 2. Let's have a look then at example 2, where it's a little bit trickier because if you look at the second point, we haven't been given the y coordinate, and that's what we're going to find. However, we have actually been told the gradient here. So the first thing I'm going to do is work out what the gradient is in terms of a, so in terms of this algebra here. So I do y2 minus y1. So I do a, the y coordinate of the second point, minus 5. And then I just do 4 minus 2. So I know my gradient in terms of a is a plus 5 over 2. However, I know that it has a gradient of minus 1. So I know a plus 5 over 2 must be equal to negative 1. Then if we just simply rearrange this equation to solve it for a, I get a as negative 7. Moving on to example 3. Similar sort of problem in that I've not been told one of the coordinates here. So in terms of the second point, I don't know what the x coordinate is. So we'll start off by doing a similar thing. We'll do minus 3 minus 8, so y2 take away y1, and then we're going to have x2, which is just b, minus 5. And I know that that is going to be equal to the gradient, which is 2/3. So if we just start to simplify this a little bit, we have minus 11 on top, b plus 5 on the bottom here, and then we've got 2/3, okay, because that's our gradient. So now what I'm going to do is I'm going to multiply both sides by 3, and I'm going to multiply both sides by b plus 5. So just be careful on this right hand side. We do 2 times the b and 2 times the 5 as well. There'll be other ways you can rearrange this. And then take 10 from both sides. And then I'm going to divide both sides by 2. This gives me our final answer of minus 43 over 2. In pure maths, we will often leave our answers as improper fractions, which might seem different from GCSE, but leaving the answer as this is absolutely fine. There'll be a lot of cases where actually we definitely don't want to write a decimal, so it's a really good habit to get into the practice of leaving your answers as improper fractions. Now we're going to look at the form of the equation of a straight line. So there's 2 ways that we can write the equation of a straight line. The first, probably the most common from GCSE, is y equals mx plus c. M is the gradient and c is the y-intercept, okay, where it crosses the y-axis. The other form is ax plus by plus c equals 0, where a, b and c are all integers. They are all whole numbers, okay, positive or negative whole numbers. So it depends on the question. Sometimes a question will ask you to leave it in the first form, sometimes the second form. If it doesn't ask you for either, just make sure that you leave it in one of these 2. So let's get into example 4. y equals minus 6 plus 4. And we're going to write down the gradient and the y-intercept of these lines. So the gradient of this first one is going to be minus 6. Okay, because the gradient is just simply the coefficient of x, and it's in that form y equals mx plus c. The y-intercept is going to be 4, okay? Or you could also say, if you ask for the coordinates, you would say that it crosses at 0, 4. Yeah, again, that's because this is your plus c part. For the second problem, we're going to need to rearrange this equation into the form y equals mx plus c before we can state the gradient and the y-intercept. So, I'm going to add 3y to both sides and divide both sides by 3. Make sure that you divide both terms here on the right hand side by the 3. And then we're going to state that the gradient will just be 2, because that's the coefficient of x, the number in front of the x, and the y-intercept is going to be that plus c, that 2/3, okay? Or we could say it crosses the y-axis at 0 and 2/3. In example 5, we're going to do the opposite now. Rather than write these in the form y equals mx plus c, we're going to write it in this form ax plus by plus c equals 0. Now the first example, all we're going to do is just add 2x to both sides, and we're going to take 1 away from both sides. Basically, we're going to get everything all onto one side so that we've got 0 on the other. Note that I could have also taken away the y from both sides and had minus 2x minus y plus 1 equals 0. That would also be correct, even though they look quite different. They still are the same equation. Looking at the second problem, what I'm going to do first is I'm going to multiply both sides by negative 3. Okay, so now what I'm going to do next is just simply add 3y to both sides. And this would be my answer. Okay, yeah, again, there's different ways that you could go with this. You may also have minus x minus 3y plus 15 equals 0. But the key thing here is we have to make sure we don't have that minus a third or positive a third in front of the x. A, b and c all need to be integers. Finally, on the last problem, I'm going to multiply both sides by 4. Because that gets rid of both my fractions. If I only multiplied by 2, the last term would still be a fraction. And then I'll just make sure that everything is onto one side. As so. Yet again, minus 2x plus 4y plus 7 equals 0 is also a correct answer. The next example, we're going to find where a line meets the x-axis, what we know as finding a root. So if we have some axes here, what we're talking about is where does it cross the x-axis. So let's say I just have a line like this. We want to find the root, okay, where it crosses that x-axis. And we can do that by just letting y equals 0. And that's because every point on the x-axis has a y-coordinate of 0. So in my first example, I'm just going to simply substitute y equals 0. So sub in y equals 0. So 3x plus 5 equals 0. And then we just rearrange to get x equals minus 5 over 3. The question asks for coordinates. So my coordinates would be minus 5 over 3. And then my y coordinate is just simply 0. Okay, as I mentioned before, all the y values on the x-axis are just 0. So that would be my final answer. For the second one, yet again, just sub in y equals 0. What that leaves us with is 2x plus 6 equals 0. Rearrange to get x equals negative 3. So it's just minus 3, 0 is your final answer. In this final part, we're actually going to find the equation of a straight line. Now, to do this, there's two key pieces of information we need to know. We need to make sure that we know at least one point on the line, and we also need to know the gradient. Sometimes you might just know 2 points and no gradient, but you can find the gradient from those 2 points, as we saw earlier. In the past, you may have just used y equals mx plus c to come up with your equation for the line, but there is another way that you may have not seen before, and it's using this notation of y minus y1 equals m bracket x minus x1. You will see this quite a lot, and this can be quite useful for when you've got a fractional gradient, just helping you rearrange. If you have done it before with y equals mx plus c, you substitute everything in, and then you get your equation from there, and that works for you. That's absolutely fine, but there is this other way of doing it as well, which I'm going to demonstrate for the rest of this video. So first question, find the equation of line with gradient 3 that passes through the point minus 1, 2. So this has met my two criteria. I know at least 1 point on the line, and I also know the gradient. So I can just go straight ahead and substitute into that formula. So I'm going to write down all that I know. And I know that m, the gradient, is 3. And I know that x1 is minus 1. So I've got this x coordinate. And also I've got this y coordinate of 2. So x1 is minus 1, y1 is 2. So now I substitute it into y minus y1 equals m times x minus x1. So just sub all the numbers into here, as so. Just be careful, of course, because it's minus 1, so you should have x plus 1 in the brackets. And then I'm going to expand the bracket. And then I'm just going to add 2 to both sides to get y equals 3x plus 5. You need to leave your answer in the form y equals mx plus c or ax plus by plus c equals 0, unless you are told a particular form to leave your answer in. In this second question, example 8, we need to find the equation of the straight line passing through these 2 points. So if I go through my criteria, I do have at least 1 point on the line. In fact, I have 2, but what I don't have is a gradient. So the first thing I'm going to need to do is find the gradient between these 2 points. So first off, going back to what we did at the beginning of the video, I do y2 minus y1, and I do x2 minus x1 on the bottom. When I do this, I've got minus 4 over minus 2, which just simplifies down to 2. So now I know the gradient is 2, and I can choose either one of these points. I'm just going to choose the first one, so I'm just going to choose the 4, 1 as my point, but this will also work if you use the 2 minus 3 as well. So I substitute it into my formula. So I'll do this on the right hand side here. So I use y minus y1 as follows. As you get used to this, you might not have to write this out every single time, but whilst you're practicing, it's probably a good idea to do so. Write down the formula you're using. Substitute your numbers in. Expand the bracket. And then just rearrange into an appropriate form. And that's it. final example then, we're going to find in the form ax plus by plus c equals 0. So this time we have actually been told a particular form that we're after here. And we're going to find the equation line passing through these 2 points. So yet again, I have at least 1 point, but I don't have the gradient. So I'm going to need to find that gradient first. So I'm going to find the gradient by firstly doing y2 minus y1 and then x2 minus x1 to get minus 3 over 2, which is then going to simplify to minus 3 over 4. So I've got a gradient and I know at least 1 point. This time I'm going to use the second point just because I've not got a fraction. It's up to you which one you want to use, but I'm going to use the second point, 3 minus 2 there. And yeah, again, I'm just going to write down one more time the equation that I am using. Substitute your values in. So this will be y plus 2 on this left-hand side. Okay, it's y minus minus 2. Put in your gradient, which is minus 3 over 4. And put in your x1 there as well. I'm going to multiply now both sides by 4. And then I'm going to multiply this bracket out to give me the following. So just be careful, I'll just sort of go through that again. I've multiplied both sides by 4, so on the right hand side the 4 just goes from the bottom of that fraction, leaving you with that negative 3. But I have to make sure I times that left hand side by the 4. And then on the right hand side, well, I've still got that negative 3 in front of the bracket, so when I expand it I need to times that x by negative 3 as well as the minus 3 there as well. Then we need to rearrange it into that form ax plus by plus c equals 0. So I'm going to add 3x to both sides. I'm going to take 9 away from both sides. And then I've got my final answer. And that's it for this video. Have a go now at the exercises that are below. They're also on the team as well. If you've got any questions, please let me know. Remember, please post the questions in that P01 chat, because it might help other students have similar questions as well.